Hi, good afternoon, everyone. Before we begin, can you please confirm that you can hear me and see the slides clearly just by typing yes in the chat window? Also, please feel free to introduce yourself, your name, your designation, company, and the country you are based in. It's great to see an international audience of people from all industries and backgrounds. Good to see you all. Okay, I have received some confirmations, so great. Thanks for confirming. I would like to thank you all for registering and taking time out on a Sunday to learn about the understanding and fundamentals of API 580 and 581 and overview of implementing RBI study. My name is Aisha Khalik and I will be your introductory speaker for today. It's our pleasure to host this webinar for you. This is our 72nd webinar in a series of technical webinars we are conducting. As a practice, we are conducting one webinar every month. Please follow us on LinkedIn and YouTube to make sure to check our website for the latest updates. Today, we have quite an experienced panel of speakers with us. I'm with my colleague, Mr. Ejaz, Managing Director, Principal Integrity and Safety Consultant, Mr. Anthony Williams, who is the General Manager, Global Sales, and Mr. Ali Arslan, who is the Head of RBI Department. Moving forward, during this webinar, we encourage you to keep asking questions to clear any doubts. We would definitely like your engagement on this topic. You can type your queries in the Q&A window, and you will receive a reply in the Q&A window, or we will answer it live. We will try to answer questions as much as possible during this session. As we will have a detailed question and answer session after the completion of this topic, please accept our apologies if your question is not addressed due to the high volume of questions we usually receive. So we have to be selective. Furthermore, we will also be issuing participation certificates to all those who have attended at least 80% of the webinar and have participated in the discussions through question and answers. Before we begin, although most of us are in the comfort zone of our homes, we should be aware of emergency exits. We should keep a safe distance and generally take care of ourselves and those around us. Since this is a quite technical subject, we will touch only the key theoretical and practical aspects of understanding the fundamentals of API 580 and 581 and overview of implementing RBI study. In this limited time of 2 hours, we request you all to follow along with us and keep asking questions to help us make this session as engaging as possible. Today, we will be covering Velosi introduction, an overview of risk-based inspection, RBI orientation topics, case study introduction, RBI approach, findings, VAIL-Plant software demonstration, and question and answer will be at the end. I will hand over it to Mr. Ijazul Karim Rao, Managing Director, Principal Integrity and Safety Consultant, who will start with today's topic.
Good day and assalamu alaikum everyone. There are different time zones in different countries, so good day is a better way of saying the greetings. The title is, for me, is a very older title, and we are refreshing it today. This topic is still popular, and the number of registrations are quite high today as compared to the previous participations. So we will be covering the concept of RBI for the experienced guys, experienced people, or engineers, technicians. It would be a repeated topic, but people, for them, RBI is a new topic. Then it would be a basic kind of information. Like before we go to RBI, RBI is a part of AIMS, Asset Integrity Management System strategies. This is one of the strategy which is applicable on static equipment. And why it is required? Before we go, I see some people are raising hand for the questions. You can write questions in the question answer windows, and then we will be answering in between the breaks. We'll have at least one break in between. We'll answer some questions, and then we will also have a question answer session at the end of the session as well. So, like, there's one incident which practically I worked on the investigation side as well, and this was a fire accident in a Pertamina refinery in Indonesia. It occurred on August 7th, 2000, and this fire basically started in a 6-inch or 4-inch line around the overhead debutanizer receiver drum, and preliminary investigation, it was found that more chlorine was being injected to enhance activity of catalyst for platform reactor. This led to formation of excessive ammonium chloride, which caused excessive localized corrosion, rates, pitting, and leaks. The main cause was excessive localized corrosion due to chlorine injection. Another incident where like a safety case started, it was back in 1988, where Piper Alpha incident, where 167 people were killed, and it was a drilling compression unit, and it was a drilling platform, and it was a huge loss in North Sea, and it basically helped to create new safety case for HECS management system under HEC Executive UK. There's another incident which occurred in Houston, and in 2005 there was a refinery fire, and it also caused 15 people's casualty and asset loss as well. So these three incidents are just being shared like we need to carry out inspections, we need to have a preventive corrosion management program so as we can avoid unexpected incidents. Why aim is required in the 4 stages, somebody can say, but the most important is a protection of basically health, safety, and environment. But there is on top of that, protection of the capital investment. In a refinery nowadays, almost $10 billion are invested. And if any fire goes, it means there's a big disaster financially. And then if people might be injured, there could be fatalities, there's the effect on the environment and health as well. Then we also need to ensure continuous supply chain. When there was a fire in Balikpapan refinery in Indonesia, for next 3 months, there was a shortage of diesel and gasoline in that region. So it means there are supply chain issues as well. Then protection of your company brand is also important. So these are the 4 stages, but normally important to have aims system. And RBI, as I said earlier, is one of the aims sub element. So what is practically asset integrity in normal sense? One of the company has defined asset integrity in 3 phases: design integrity, technical integrity, and operational integrity. Design integrity means when facilities are being designed, so they should be designed in accordance with international codes and standards and with best industrial practices, so as design-wise there is no flaw or no loophole. The technical integrity means when plant is constructed, installed, and after that we need to operate the plant with due inspection and planned maintenance activities to be done also. Operational integrity means the implementation of basically integrity operating windows, and those integrity operating windows mean the plant should not exceed any design limit defined by the process licensor or in the P&IDs or as per the set points for the alarms, for the trips, and other information. Then, like how RBI process works normally, see, RBI, as I said earlier, there are basically 3 mechanisms which are used for inspection and maintenance planning. RBI is applicable for static equipment, SIL, safety integrity level, that is applicable on basically SIFs or the safety instrument functions, or ESD system, you can say, or fire and gas detection system. Then RCM is a system which is applicable for like normal rotary equipment, electrical, and instrumentation. So normally we call it RBM, risk-based maintenance strategies, as one of the AIM subsystem. And RBI provides you like inspection plans, equipment functional test, like these 3 things basically, not RBI only. These 3 studies, which are the basis for implementation of any CMMS or IMS system. And they provide you inspection plans, equipment function testing intervals, preventive maintenance program, operator surveillance rounds, then first line maintenance task if required, condition monitoring, online maintenance, offline maintenance, turnaround tasks. All these outputs are coming as a result of these three studies. So, basic theory point of view, what is RBI? RBI is risk-based inspection. Is a method for using risk as a basis to prioritize and manage the efforts of an inspection program. It is systematic analysis that establishes the risk levels associated with the operation of each piece of equipment and tanks and ranks them accordingly. It is an inspection planning methodology as well. Basically, if we say risk-based inspection, it is evident from its name, like we will be prioritizing our inspection activities based on the risk being assessed for each equipment, including piping, pressure vessel, heat exchanger, and tanks. And since RBI is mainly focused on the static equipments. Aim of RBI orientation, like what we will be trying to understand today, to facilitate understanding the management commitment and employees' involvement to the concept of RBI and to embed this on work practices within the organization. Like what is like how RBI system works, how it can be implemented to any organization, and how it can be made effective. The objective of this session means like what we'll be covering here is like a step point of view. The first step start with like what kind of data required for RBI assessment, then what is the methodology of risk assessment, how risk assessment is done, then what are the results of risk assessment and risk ranking. After risk ranking, how we do inspection planning. And when inspection planning is being executed, what are the lessons learned and how the mitigation is done for the active damage mechanisms. And then once we have inspection results and mitigation results known, reassessment for the change or upgradation of the RBI strategy. Like why RBI is important? First of all, the facilities are exposed to various damage mechanisms, and we need to understand what are the threats being faced by our facilities and how we should manage them. Number two, equipments are getting also older, and the damage mechanism could be more aggressive. Then there are many, like the size of the facility is quite big, and there are many equipments and piping systems where we need to apply inspection planning. So there should be some tool which can help. There are various damage mechanisms which are applicable on the facilities. So then the price per barrel of the product, like we need to have optimum cost for the inspection activities. Then next thing, challenges point of view, like degradation mechanisms are there, and causes of degradation mean there are normal operation, upset, startup, shutdown conditions are there, material environment condition, interactions, many combination of corrosive process streams and temperature pressure conditions. In the absence of corrosion, mechanical and metallurgical deterioration can occur. Like if corrosion is not there, then mechanical and metallurgical like effects could be there. There could also be weather effects. So as per API 571, there are now 68 almost damage mechanisms which could be applicable to oil and gas industry equipment, and there are internal, external, temperature-based, aqueous-based, or high temperature-based. So those all damage mechanisms we need to assess, and then we need to see like what kind of technique could be applied first to mitigate those damage mechanisms, and then if what kind of inspection techniques we should apply to predict before any failure could occur. Like other integrity and like inspection issues point of view, safeguarding the plant integrity is another part. Like identify the problem, the location. Like when we're making any inspection plan, so normally we say there are 5 W's, like what, where, how, who, and when. Answer is required. So it means what mean which equipment and what problem. The location is where, detection method how, competent staff who, and inspection interval mean when. Then inspection issues, like not all equipment can be inspected all the time. Similarly, one inspection technique may not be applicable for each equipment, and there could be various schedule related timing, like when which equipment is required to be inspected and by which technique and by who. So all those 5 W's are kept in focus to manage inspection issues in general. and how much inspection is appropriate, 100%, partial, 5%, 10%. So those issues are also important while doing RBI. The general objective, as I said, is the same thing, like optimization of visual and entity inspection plans, enhance plant integrity and profitability by risk management, identify the high risk items, understand the risk drivers and develop mitigation plans, focus inspection plan which increase safety and reduce risk, assist to improve reliability, often result in cost benefit due to following: reduced turnaround time is not always necessary, sometimes cost also increase, but in general this is the concept. A reduction in number of items to be inspected, a reduction of low risk monitoring locations, the associated maintenance cost, for example, excess arrangement, normally an overall reduction in risk and cost saving from inspection act. So there are two ways to do inspection. Like one side is do not fix it unless it is broken, or time-based inspection program. This is one side. Other side is comprehensive inspection program after RBI analysis. So choices are there. It could be combination of both as well. Then development of coherent loops is one of the opportunity with identification of applicable damage mechanisms. So there is a coherent loop drawing we'll show next. Help in identification of 10 to 20% high risk items as indicated by Pareto curve, which is applicable on every like a part of life, and is also applicable on the equipment. Generally, 10 to 20% equipments are more critical, and similarly 10 to 20% equipments are also very less critical. So in between there are about we can say 60% equipment which travel from low risk to high risk in between. General inspection plans based on applicable damage mechanism and risk basically generate inspection program. This is RBI. Then this information is being driven from API 580, 581, and 571 standard. What are the applicable regulations and industrial standards in the RBI program or the static equipment program? So in general, API 510 is for pressure vessel, 570 for piping inspections, then 571 is for damage mechanism, 572 inspection practice for pressure vessels, more detailed, is a combination of 510 and 572. 570 and 574 are read together for piping. Then API 580 is a risk-based inspection standard. Then a risk-based inspection technology is API 581. 580 is a short standard, is a more detailed one. Then API 584, integrated operating windows, and API 650 should be API 653, which is in like for tanks in service inspections. 650 is for the basically new tanks. Then there are ASME standard also, which ASM International Korean in the petrochemical industry. There are also NACE standards, which are not referred here. Then ASME 31.3 for pressure piping, ASME Section 8, Division 1 and 2 for pressure vessels. Then we have RBI like a methodology, what Velosi is using, risk-based inspection methodology for pressurized equipment and piping system. And this is basically for semi-quantitative and quantitative methodology. Like how these standards are evolved over the period. Many of you might be aware, like previously API 750, API 510, API 570, and API 653 were previously existing standards. And then there is a generation of API RBD. This exercise was done from 1998 to 2000. And it was a risk-based inspection program was developed. Then same time there was MPC, fitness for service, also being generated at that time. And then based on these two exercises, API 580, 581 standard was issued, and then FFS API 579 standard was also. So this like by this mechanism, the working document, then research document, and practice and standard which are evolved. So these two standards are quite effectively used nowadays in the industry, along with API 510, API 570, and API 653. Then like let's look at like what is the title and content list, just for the people who are new, for their awareness. See, this is a risk-based inspection. Basically, it is a recommended practice. The purpose of this document is to provide user with the basic, minimum, and recommended element for developing, implementing, and maintaining RBI program. It also provides guidance to owner, user, operator, and designer of pressure containing equipment for developing and implementing an inspection program. If you see the title point of view, content point of view, see, it covers like a basic risk assessment concept, then introduction risk assessment, risk-based inspection program, then planning for the RBI assessment, then all the steps are the data collection, then assessment of the consequence of assessment of the probability of failure, then risk assessment, inspection planning, so and then other risk mitigation activities. There's API 580 program, and many people are appearing in these exam and passing. So it's a quite simple one. Once upon a time also appeared and passed. So this is one standard which gives you basic information about the RBI program as such. Then where is API 581? Previous name was like a base resource document. Then it changed to the name risk-based inspection methodology. It's a more detailed, quite thick standard. And it got three parts: inspection planning methodology, probability of failure methodology, consequence of failure methodology. There are appendices also. It is a quite detailed standard and self-explanatory and easy to use. Like this is the, if you say part one, this is part two, if you can see it. This is part three. Since I got time limitation of maximum 2 hours, so I may not go to all those details. Otherwise, like it's a 3 to 5 days course when we cover both API 580 and 581. Topic point of view, like if we try to go through, see, it's a basic information, and then we'll be sharing the case study, and then at the end I will also show or demonstrate our RBI software. That would be the end. But the people who are new, just to make them familiar. So the first thing is like a term and the terms and definition. Then what the RBI process, which I've been discussing. So there will be some repetitions, and normal definition, probability, likelihood mean the chance that given event will occur. Failure mode mean the manner of the failure. For risk-based inspection, the failure of concern is a loss of containment of pressurized equipment item. For example, failure modes are pinhole, leak, crack, or rupture. Hazard mean a physical condition or a release of hazardous material that could result from component failure and result in human injury or death. Then mitigation mean limitation of any negative consequence of a particular concern. Then risk assessment mean is the probability, like a overall process of risk analysis and risk evaluation, which consists of deciding whether or not the risk is tolerable. Unmitigated risk means the risk prior to mitigation activities. Consequence means outcome from any event, like if something goes wrong, what are the effects? Deterioration is a reduction of material ability to perform its intended basically function. Then failure means terminology of the ability of a system, structure, or component to perform its required function. Event, occurrence of any particular set of circumstances. External event, an event beyond the direct or indirect control of management and staff of the facility. Risk, the combination of probability of an event and the consequence of failure. Risk analysis means systematic use of valuable information to identify hazards and to estimate the risk to individual or population, property, or the environment. What does RBI mean? This is the same what we have been discussing in past. Like we're just getting you familiar with the terminologies. So just please bear with me. RBI is a method for using risk as a basis to prioritize and manage the effects of an inspection program. It is a systematic analysis that establishes the risk levels associated with the operation of each piece of equipment, piping system, and rank them. It is an inspection planning methodology. I covered earlier also. Then what is risk? Risk means probability of failure multiplied by consequence of failure. Risk after RBI mean alarm as low as reasonably practicable. The issue is like in plant, it cannot be risk-free because there is a hydrocarbon which is inside the pressure vessels, the piping systems. There is air outside which contains oxygen, and it means only ignition source is missing to create the fire. It means whatever we do, the triangle of fire exist around the hydrocarbon facilities, and we have to take that risk, but we need to manage. Then probability of failure, as I said earlier, definition also extend to which an event is likely to occur within the time frame under consideration. The chance that a given event will occur is called probability of failure. The number of possible events divided by total number of events. POF of is mainly dependent on two following factors. Number one, deterioration mechanism, corrosion mechanisms, which are applicable on the due to operation. For example, if a surface is thinning, cracking, CUI, those all aspects. Number two, what kind of inspection is being done and how effective is the inspection to predict what damage mechanisms could be there and how those could be mitigated or prevented. Then age is also important. So probability of failure is normally in the as per API 581. There is a generic failure frequency. Then there are factors which are related to age, which are related to applicable damage mechanisms, and inspection confidence and inspection effectiveness. Then consequence of failure mean if something goes wrong, it might have effects on safety and health impacts, environmental impacts, and economic impacts. See, in general sense, probability increase from bottom to this sort of risk matrix. Probability of failure occur increase from lower to this side, and then consequence also increase. So this is the low risk area, green, and high risk area. With the passage of time, the probability consequence remains same, but probability of failure keep changing or increasing. So we need to keep risk in acceptable range. And this is other understanding, this is a probability of failure, which could be low, medium, high, very high, and these are the consequences, which is economic, environmental, or safety. And this is a scale, and this is a high risk, this is a medium high risk, medium risk area, and low risk area. Credibility of RBI and its type. See, RBI, if it's done with the right methodology, with the trained staff, is very useful. But if it is not done by the right methodology with the right resources, then there is a risk. And as per API 580, 581, there are three types of RBI studies which could be done. First one is qualitative, which is simple one. Semi-quantitative analysis, which is medium. And quantitative means it's a full based on calculations and by using quantitative software. So that is one part. So level one is qualitative analysis. Mean qualitative analysis based on initiative assumptions of probability of failure and consequence of failure. It is a judgmental, where some experts sit together. They say what is the probability of the failure due to what damage mechanism, what is the consequence due to what effects, and then it is a quite simple analysis. Could be based on the spreadsheet analysis. Semi-quantitative mean it could be a more detailed one where some calculations, some assessment, some judgment, and then the result could be included, and then inspection planning can be done. Level 3 is a more detailed calculations and where the damage mechanisms, growth rate, then damage factors, and based on the damage factor, probability is calculated, then consequence also calculated based on the quantitative analysis, then risk, and then inspection planning. So this is a more detailed analysis is also available, and it's called quantitative analysis in accordance with API 581. See here, if we try to see plant data assessment, risk ranking, and at the end, we have to have a specific inspection plan for a vessel, for a heat exchanger, for a tank, or for a piping system. This approach is also applicable on the structures and also pipelines. What RBI basically covers normally, it is covering, as I said earlier, pressurized equipment and piping systems. There could be transmission pipelines. There could be supporting structures, and it could also be applied on the ships and hulls of the ships. And in general, wherever there is a static kind of equipment, there's no rotating component. Rotating component cannot be covered under RBI because they are more complex, and we are used to follow FMEC approach for the rotating equipment because their damage mechanism or failure modes are more complex as compared to static equipment. In static equipment, mostly damage mechanisms are divided into linear kind of damage mechanisms, which is like internal corrosion rate, external corrosion rate, which with the help of corrosion rate, we can determine the remnant life. But there could be some cracking probability as well. And there are also some time independent damage mechanisms, if you see, like I would say, example point of view, brittle fracture. And that is independent of the time. So these all damage mechanisms are causes where applicable. So those equipments are covered under RBI program. So static equipment are covered under RBI, and rotating electrical instrumentation are covered mostly under RCM. SIL is applicable on the SIPs or fire and gas detection system. So this I covered already. The main equipment are in-plant piping, pressure vessels, reactors, columns, drums, then heat exchanger and fin-fan coolers, then filters and tanks. See, normal RBI process, what we takes like how we do it, required data, that's what all we need to collect, identification of assets, preparation of asset register, preparation of clean loops, and we identify damage mechanisms. We also identify IOWs, mean integrity operating windows, risk assessment, both probability of assessment, probability of failure calculation, consequence of failure calculation, risk assessment, and also then we do inspection planning. These are the steps for the RBI study. Before I start my case study, if there are questions, I would like to answer. Kale, you can please read. Yes, the certificates will be shared. There's one question, right?
Okay, so for everyone, we're receiving some question and answers. Yes, we will be posting this on YouTube after 2 to 3 weeks working weeks. Next one is all certificates, including CPD and completion webinar certificates, will be shared through your email after the completion of this webinar.
You will receive it within the next 2 days, right?
Yes.
Okay. Questions.
Let's go to the question and answer. One question is, why RBI is used only for static equipments and RCM is specific to rotary ones?
The question, I think I tried to touch base this question earlier also. Static equipment are basically simple to manage, and API 571, API 580, and 581 can broadly cover the static equipment related issues. Whereas rotary equipment, where you got a rotating shaft, bearings are there, and if you take electric motor, it got there's a generator or electric winding is also there. Then if you take a turbine, it's called combustion chamber, then gas path, and then the machine turbine. And similarly, if you go to pump, so pumps are also impellers and process of the fluid handling. So since the issues in RCM are more complex, and somebody can say RBI is a sub part of RCM, because if we try to apply RCM on any, let's say, tower or reactor, so in that scenario, internals normally we try to handle by RCM approach, and the pressure containment or body of the pressure vessel or reactor by RBI technique. So it's a combination of both, but RCM is normally more broader, RBI is more specific. See, there is a question regarding there was a fire in ADNOC refinery also here. As per the information which reached to us, that was mainly was not caused by corrosion. It was caused by like a loss of control during the maintenance activity. There was a basically problem with one of the naphtha pump, and the maintenance was being done on that naphtha pump, and the pump was isolated, and there was spectacle blind, and upstream of the spectacle blind, there was basically butterfly valve. And during after repair, when they were trying to attach the pipe with the pump nozzle, the butterfly valve got opened, and the flow of naphtha started, and basically the staff ran away, and that caused the leakage. This is information what we heard, and it's not like as such official, but that was the main cause of that accident. And there was issue like what other causes were there, and why hydrogen was being injected at upstream of the pump, which was causing more problems on the pump itself. And then normally you don't use the butterfly valve in hydrocarbon service. Normal gate valve or ball valve, or like these valves are used, but they use butterfly somehow. So those were the reasons, and it caused at least $3 billion loss for ADNOC, as we heard or we see in the media. But it is unofficial, and we should not spread rumor as such. And it has been managed now. Refinery is in operation.
Next question. What methods of damage prediction and corrosion models integrated into your system? How?
So, so in our system, all like applicable damage mechanism in accordance with API 581 are modeled, and modeling is available.
And the following question is consequences and magnitude of consequences realized in your software?
Yes, we have 3 levels where we do consequence analysis, level 1, level 2, and level 3.
Next question. Do we have to certificate API 580 for inspection engineer?
No, API 580 is for RBI practitioner. For inspection engineers, the API applicable mechanism is API 510 certification, API 570 or API 653 certification program. API 580 and API 571 are related to RBI program.
Next question. Does RBI involve preventive action study or corrective?
It's both. Prevent, like when it's a mitigation program or a preventive program that goes to preventive as well, like corrosion inhibitors injection or management of dead legs, management of injection points, and like a coating and like a painting program. These are all are the preventive programs, or maintenance of the integrity operating window is also part of preventive program. So RBI covers both preventive as well as the reactive program.
Next question. Does AIMS contains both stationary and rotary equipment or only stationary?
AIM is applicable on all facilities, like even like not stationary rotary, also in electrical instrumentation, structures, pipelines, hull, you name it, like a complete facility, even buildings are covered as a part of the AIMS program.
Next question. Is the corroded oil pipeline can cause fire and might compensate the quality of a product if the corroded particles have accidentally mixed into it?
Yes, there are sometimes in the gas pipeline, brown powder comes as a corrosive material. So yes, like as I said earlier, if there could be any ignition source near any leaking point, so then hydrocarbons are coming from the pipeline and oxygen is available in the air. If ignition source comes in, then there could be a fire, and fire is always a catastrophe.
Next question. While implementing RBI program, can we exceed maximum inspection intervals set by API codes? For example, as per API 510, maximum internal inspection interval is 10 years. Can we exceed this interval through RBI?
See, those decisions are made based on the availability of previous inspection data. And if inspection data says there's no trend where the applicable corrosion rate is not so high and within acceptable range, and all the preventive programs are in place, corrosion inhibition program is in place, and integrity operating windows are being maintained, then inspection program interval can be extended. Yes.
Next question. Are RCM, SIL, and RBI are the only AIMS strategies?
No, these are the 3 strategies which are coming for inspection and maintenance planning program, right? Like what should be the testing interval for a SIF or a ESD system or fire and gas detection system. So SIL provide that mechanism. Formulas are there. Similarly, RBI provide inspection like interval calculation program, and that's available. Formulas are available. Similarly, for RCM is a FMECA based with MTBF, like a mean time between failures, that provide a basis like what should be the testing interval or function preventive maintenance program interval. And all these basic philosophies, any inspection program or inspection interval or maintenance interval should not be like less than or more than, in general, half of the attended life or half of the time of the mean time between failures. So that is a formula. So these 3 techniques are used for inspection planning and maintenance planning frequencies and activities.
Next question. How can I get a practice in an RBI system if I don't work in a company that have one?
See, unless and until you come across the working practice, you don't work with the people who are trained it is always a challenge, and there's no easy way. Like if we need to learn anything without going to school, so it will become difficult.
Next question. What is FS 579?
Yeah. API 579 is a fitness for service standard, and we have separate program. And if you go to Google API 579, you can get more detail from the Google.
Next question. About the RBI philosophy, the aim point needs to clarify the colorations all of teams, especially the production, can affect the outcome of the RBI.
See, RBI program point of view, consequence point of view, there are three aspects, like with reference to safety, environment, and production. And the stakeholders like are participant of the RBI process normally involved, like a corrosion, inspection, process, and operation people. So these all people are working jointly, basically.
Next question. Under which inspection the tank bulging of storage tanks could be detected, and can we generate custom tank calibration charts that covers bulging effect in account?
See, first of all, bulging is a engineering failure. Like if a vessel is designed to API 650 or 620, API 620, and their thickness are adequate, their floor is made on a proper foundation, and there's no settlement, then why there should be bulging in the tank? If there would be bulging, it means the thickness was not enough, and there is some sort of abnormality. Secondly, when you go to normal calibration of the tank, it is a formula like actual volume being contained within the tanks and all the dead zones. For example, a space for the manway and space for any like a sport. So something has to be added, something has to be detected minus. So it's not so easy, but it's not part of RBI exercise. Calibration is a separate methodology, and those calibration methodologies are used. But bulging normally is not being covered by RBI, it is covered by mechanical design. Okay.
Next question. What are the outcome of RBI study?
To like what should be the inspection program, like what inspection techniques like visual inspection, UT gauging, UT scanning, MPI, or MFL, IRS, eddy current, whatever technique is applicable to type of equipment, what should be its frequency, then what is the risk level, and what are the driver of the risk, probability point of view, and consequence point of view.
Next question. IOW, is the best choice for RBI or not?
No, IOW is a normal, like when we design a plant or any facility, we know that what parameters we need to maintain. And those parameters, for example, with respect to, let's say, temperature, pressure, flow, level, pH, water content, or any other corrosive element content. And if the facility is designed to maintain those conditions where there would be no abnormality for the equipment, we are required to maintain those parameters. And there are controllers installed on the plants, like whether it's level, whether analyzers, whether flow related, velocity related. So those parameters are required to be maintained within the specified limit. Otherwise, there could be any abnormal result.
Next question. What is the contribution, construction deviation, or failure to identify the same during the construction in RBI evaluation?
See, whether you go to piping or pipeline, the issues which are inherited from the construction phase, whether let's say the base metal is supposed to be a hick resistance for a source service, and we have brought dirty steel with the lamination, then it would have more problems. Similarly, if there are welding related issues which are left in the weld zones, even RT detected those and those repairs were not done, then those problems will be carrying problem for future. So the issue is the QC controls at the construction stage, at procurement and design stage, those are mandated to be met in accordance with applicable standards. And there is a delegation of responsibility from one phase of the plant to the other phase of the plant. For example, there is a design stage, there is a procurement stage, there is a construction and installation stage, and there's a commissioning and pre-commissioning stage, and then there is operation phase. So each phase has to take the due responsibility. If there is any punch list that can be carried forward, otherwise there's no guarantee plant will operate normally.
Next question. Is there a risk-based inspection methodology or standard practice for FACS or flexible alternating current transformer system devices?
See, FMECA is a technique like on those equipment, whatever the failure mode applicable, what are their causes, what are their maintainable items, what are their effects, what are their MTVF, and then we see what kind of preventive maintenance routines can be taken care or can be implemented.
Next question. While planning for RBI inspections for offshore platforms, what will be the main factors?
See, for offshore platform, as per our RBI program, there are 7 factors which are related to probability, and there are almost 5 or 6 factors related to consequence. Let's say if I go one by one, the one is the corrosion related issues, number 2, utility factor, number 3 is the fatigue life, and I don't remember that there are 6 factors are there, consequence point of view effects also. So the structure related approach is based on API 2 SIMS. So today I'm covering mainly static equipment, piping and pressurized vessels, but we do have a program for the subsea structures as well.
Okay, for last question before we can continue. One participant wants to know that, like in simple words, how can you differentiate API 580 and 581?
See, 581 is a recommended practice, which has provided minimum guideline, whereas API 581 is a detailed methodology for RBI technology. So it provides all the formulas, all the steps which can be used to develop RBI program, even software, and like corrosion related modules can also be developed based on the modules given in API 581. Okay, sir. So now we go to the case study, and after the end of this case study, we will come back to the question answers one more time. Please keep writing your questions, and we are very glad when there is a more active participation. So, like this is one of the project what Velosi has done, and the main objective program which was given to Velosi was establish equipment and piping corrosion loops and identify the dominant damage mechanism, perform risk assessment on selected equipment and piping to identify critical assets, increase the safety of plant by minimizing the risk, development of inspection plan. So basically, it was a 3-year program where both A and B facilities, the name we have changed, and this contract was given to us for the period of 3 years. And in normal sense, if you can see that the pipelines also, the pipeline, field pipeline and trunk pipeline, that was a big job, practically, if you can imagine, 413 pipelines. Then there are about 500 equipments, tanks were 44, and over basically now we have completed more than 20,000 piping systems. Then there were 73 wells, and there were about 1,262 PSAs. So these are the type of equipment like breakdown, like columns, filters, fin fan coolers, heat exchangers, heaters, vessels, spheres, tanks. Total equipment 251 and piping tags 6,500. This was the field A. And this was the field B, where 4,414 equipments were there altogether. And then like what we have to do, like establish corrosion loop, identify the damage mechanisms, development of inventory group drawings, inventory integrity operating windows identification, detailed inspection plans, inspection drawings, corrosion inspection strategy, documents, and risk-based inspection study report also along with the software slide. Then, like a pipeline point of view, RBI safety valves, then wells also were covered. There's like a section layout drawings for the pipelines, mechanical assessment sheet, inspection plan, risk-based inspection report. Similarly, for the safety wells, asset register, risk assessment report, detailed inspection plan. For well also, a risk assessment report and detailed inspection plan. So there were also various inspection guidelines or inspection procedures which were supposed to be prepared as a part of this project, like inspection procedure using close visual inspection and remote visual inspection program. Then inspection procedure using ultrasonic technology, UT, phased array, and long range ultrasonic as well. Inspection procedures using dye penetrating tests, similarly MPI and so on. Supply of like RBI software, including VAIL-Plant PEMS, PIMS, PSVMS, Well Integrated Management System, and ISMS programs. So these like 5 modules we have implemented for this. Approach point of view, like what Velosi is used to follow, just like it's not necessary every company would be following similar approach, but these are based on API 580, 581 methodology, and Velosi software is also certified in accordance with API 580 requirement by third party. So we are complying with the API 580 RBI working process. Like information and data collection first, identification of asset for RBI, preparation of Trojan loops, identification of potential damage mechanisms, preparation of inventory groups, then integrity operating windows, then assessment of remnant life. This is also covered as a part. Then assessment of POF, assessment of COF, risk assessment, criteria for inspection interval, define scope of inspection, then preparation of inspection plans, and preparation of inspection sketches and drawings. Then reports were coming afterwards. So data point of view, the lot of data is required, but in general, data sheets, GA drawings of the equipment, or asymmetric drawing for piping, equipment list, P&IDs, PFDs, MSDs, piping material specification, piping class data, heat and material balance sheet along with the PFD is also important, line list, piping material specification, isometric drawing, and operating manuals. So here the same like the information data collection, what we collected, like P&IDs were about 448 and 341, a process flow diagram 90, 27, heat and material balance sheet 172 and 6, selected equipment, then selected piping system, history of equipment, equipment data sheets, equipment GA drawings, then operating manuals and process description, piping material specifications, and summary of the equipment and piping inspection, piping inspected up to date based on the provided duty records. So out of those received 472, and these were not received, meaning inspection results were not available. Identification of assets for RBI are done on the basis of provided asset list. Then the following type of pressurized equipment and component like internals are considered for RBI assessment for all these equipment. Data validation point of view, like verify that there are no duplicate component names, verify that latest revision of documents are used, check that all data entered makes sense, reality check, check for large or small operating temperatures like pressures, length, diameter, thickness, like they are basically accurate, and length is not used in diameter and vice versa. Check that assumptions made for missing data are sensible and appropriate. Like this is a Excel template as it worked, a sample asset register where you can see that serial number, then corporation company means, area, TAN number, plant, equipment position, equipment description, component tag number, component type, P&IDs, Corrosion loop category, consequence, Corrosion loop description, Corrosion loop drawing, and so on. So a lot of data is there with the sample coming. And the same, like this is a software, basically a form view, where this information is being, this is a hierarchy of the plant, and this is general engineering data. There could be drawings also attached with the, then development of Corrosion loop. Corrosion loop is a term to define equipment and piping grouped together that are similar in their process environment, made of like material, and are accessible to the same kind of damage mechanisms. Corrosion loop are developed for graphical representation of possible damage mechanism, pressure, temperature parameters, corrosion allowance, and estimated corrosion rates, made corrosion rates, a percentage of corrosive ingredient like CO2, H2O, and H2S, etc. Construction and lining cladding material also important. These potential degradation mechanisms would be identified for each corrosion loop and equipment component level as well. API 571, API 580, and 581 would be used as a reference document for degradation mechanism identification, just as a normal learning for a new engineer. Then how we make corrosion loop, preparation of corrosion loop drawing means define corrosion loops, define the equipment and piping together that are similar in their process environment, made of like material and are supposed to have similar damage mechanism. Then marking of crane loops of PFDs and MSDs. Then listing of required data of each crane loop. Then identification of damage mechanisms, like potential damage mechanisms are identified for each crane loop based on process, nature, material of construction, and so and so. Then crane loop asset register, database of crane loop consisting of all assets, equipment, and piping system listed against each crane loop along with anticipated damage mechanism. Then submission, review, and feedback from the client or workshops are also conducted with client engineers once the crane loops are at draft stage. Like this is the one of the type of the crane loop. Like here, the color wise, this is one crane loop, other crane loop, and the basic engine data is also added, material of construction, service, corrosive element. And then if you see here, these are the crane loops and these are the potential damage mechanisms, if I may say a little bigger. Okay, so this way crane loops are prepared. And API 571 is a potential like a guidance available to make crane loops. Here the crane loop A, plant point of view, crane loop number, description, and crane loop description, like a description carbon steel with PWHT, valve fluid, description point of view, and this is a name of the crane loop. So, some other area crane loop drawing, the same summary. Then dual crane loop, sample crane loop register point of view. So we are adding crane loop like here, if you see crane loop number, crane loop category, crane loop description. So data is updated into the system so as we can use as a filter. Then identification of like potential damage mechanisms to perform following validity steps in the important import spreadsheet of the software. Verify that there are no duplicate component names, verify that latest revision of documents are used, check that all data entered makes sense, check if any large or small operating temperatures, pressure, length, diameter, thickness is entered, check that assumptions made for missing data are sensible. For same applicable as explained earlier for damage mechanism as well. Then here, like internal thinning point of view, the main like for asset A, main damage mechanism, internal thinning, external corrosion, cracking, others. So like sour water corrosion, acidic, erosion corrosion is 20 number, CO2 is 42, it is a API 571 damage mechanism number. Then cooling water corrosion, then microbiologically induced corrosion make, and then it was like external means corrosion under insulation, atmospheric corrosion, soil side corrosion. Then cracking mean refractory degradation, chloride screen cracking, brittle fracture. Other mean mechanical fatigue, vibration induced fatigue, general corrosion, under deposit corrosion. So these are the type of damage mechanisms. These are the 68 altogether, but all were not applicable. So these were applicable in main. So this is for the field A, and this one is field B. Like the same damage mechanism, some difference is there. HCl is coming here, right? And creep stress rupture is also coming 3. So some differences, but these are the damage mechanisms which were applicable as per API 571. So here, like we identify thinning and mic for one of the component which is applicable, and then there is other estimation were performed. Similarly, inventory groups is a simple term used to determine the mass of a fluid that could realistically be released in the event of a leak. The inventory group is used to designate a group of equipment that can be remotely isolated. For example, like remote isolation valve locations from other sections of the plant in an emergency. Like strategy point of view, no, but there are QRA strategies, methodologies which can be used for marking of the inventory groups. For QRA, there are ADNOC standards and there are also OGP standards which mark inventory groups as isolatable sections. So isolatable sections mean if there would be leakage in a particular section of the plant, and when you take ESD action, you shut down the plant. So which part of the fluid, the section of the fluid will come out from section to from isolation point to isolation point, that is normally called one inventory group or one isolatable. Like a drawing point of view, normally the isolatable points MOVs people take. ESD, I have a doubt, like a doubt with it, but MOV is also used as a one of the isolatable point. ESD valves, blow down valves, pumps, compressors, and normally closed valves. Option 2 secondary criteria could be for use when inventory groups are very large, which result in unmanageable or very high risk. Then DCS control valves or push button can also be used for the risk reduction or for reducing the size of the inventory as per the company policy. So this is the way how we mark inventory groups on the drawing. You can see that this one value to this color is a one inventory group, and the blue one is other one, green one is other one, and how we see it as a this is a legend, and we also provide like what the service and table point of view you can see. Establishing integrity operating windows. The main standard which is taken into account is API 584. There are like a parameter that can be controlled typically fall into categories like physical and chemical, various limits on the pressure and temperature, including design, operating and partial pressure, dew points, drive points, heating and cooling rates, delta pressure, then differential pressure we call it also, flow rates, injection rates, inhibitor doses, operating levels, amperage levels on L-key contactor motors, slurry contents, hydrogen flux, vibration limits, corrosivity probes, which are weight loss coupons and ERP probes. Then chemical point of view, pH, water content, acid gas, loading, sulfur content, salt content in crude, ammonium bisulfide content, ammonium contents, total acid number, acid strength, amine strength, inhibitor concentration, chloride contamination levels, oxygen contamination in water are important. Critical limit mean a limit at which the operator has one last opportunity to return the process to the safe condition, and if exceeded could result in one of the following in a very short time. For example, catastrophic release of hydrocarbon or hazardous pollute, loss of containment, non-orderly shutdown, then significant environmental impact, other unacceptable risks, which are called critical limits, where problem may start or abnormal situation may. So like these are some definitions where we are saying what conditions are required to be maintained. For example, parameters like minimum, maximum, target range, location, reference for parameter limit, then minimum chlorine inhibitor availability, observation frequency, and RWC, whether who's responsible department. Then assessment of remnant life as a part of the review, like we have 4 kind of damage rates or corrosion rates. One is measured corrosion rate, then estimated corrosion rates, expert corrosion rates, design corrosion rates, and measured experience theoretical. So based on that, we have a trend, expert corrosion rate, we have estimated corrosion rate based on the available corrosion allowance, remnant life. We select the corrosion rate like whatever is available, and preferably it should be measured one. The second is expert one, third could be estimated, which is mostly conservative, and then we set the default or the whatever corrosion rate is available, and then we estimate the remnant life based on the available future corrosion allowance. See, in general, design corrosion rate is calculated from the design corrosion allowance, design life into multiplied by 40 in a, it's called MPY. If it's the same, it could be millimeters per year as well. In normal, like a design life of the equipment, like 25 years their design life, but actual life has to be assessed based on the available corrosion allowance and applicable damage rate. The mean corrosion rate, how we calculate it, like it is the thickness last, like a T second last measured thickness and thickness at the last measured thickness, and then the dates point of view, T nominal, T measured, the other area measured like a long short term corrosion rate and long term corrosion rate. Short term is between 2 inspections, this inspection and the last inspection, and whereas long term is the T nominal at the original stage and T measured when we are inspecting, and the time in between. By that mechanism, we calculate like nominal thickness, minimum measured thickness, metal loss, service start date, inspection date, time span, and measured corrosion rate per year. This is as per the formula given. Then estimated corrosion rate, we use the software module, whether it is a CO2 corrosion, corrosion modeling, MIC modeling, soil corrosion modeling. So for this, we provide the parameters which are applicable or that particular equipment and try to estimate corrosion rates by using VAIL-Plant software. Like this is for the CO2, where the various damage mechanisms are here, and by applying weather inhibition correction, H2S correction, chloride correction, so these correction can be applied and damage mechanism can be assessed. This is a corrosion under insulation, the similar parameters like a type of the coating, age, type, the condition of the insulation material, the model is available and that can be used for estimation of the corrosion rate for the CUI conditions. This atmospheric corrosion also, we have to provide the applicable condition, painting conditions, and then it can calculate the corrosion rate. This is for the like a live calculation for the MIC also. MIC is a microbiological induced corrosion model available. So we have to provide the applicable conditions, and then we can see that mix accessibility, whether maximum 10 is 0, or based on that F factors, we can see what is the probability of the MIC as 1. Is the low at this. Remember live calculation on the other part, same, like we have a T actual minus T required. Other formula is also there. If we have another calculation available, not a corrosion allowance, but T actual minus T required, then corrosion rate, which is applicable. So this gives us FCA, future corrosion allowance, and we can see remnant life. So this is the inspection history, which gives us the basically corrosion rate formulas here, both like a metal loss is here, right? And remnant life also given by the software. And this is the like a T minimum required, maximum. So all these aspects are available in VAIL-Plant, and all inspection technique like a visual inspection, UT gauging, UT scanning, MPI, DPT, automated UT are also available in the software, how we can record them properly and use the information for the availability of the required results and assessments. So here, once we have inspection data in the system, it can gives us also what is the remnant life of the equipment based on like what thickness is, whether UT gauging, UTS, RT, and then there could be a metal loss, short-term and long-term basis, and then both lives can be estimated. The summary around life calculation for equipment, for example, if you see that like a number of tags where life is less than, let's say 1 year is 1, from 1 to 3 is 0, 3 to 10, 7, 10 to 30, 191, total 191 calculation based on these records. So this is the summary of the equipment as per the actual working. So here, summary of remnant life calculation for equipment, 8 equipment, we have the result shown here. For example, remnant life years 9.79, 9.14, then 0, 9.86, 4.73. So this is done nominal thickness, minimum measured thickness, minimum required thickness, and then remnant life is calculated as per the formula. All details are not here. So next is the probability of failure. For example, as a risk point of view, probability 1, 2, 3, 4, 5, probable, improbable, very improbable, extremely rare. So this is like a failure probability more than 30 years, 10 to 30 years, 3 to 10, 1 to 3, less than 1 year. So this is the frequency of the scale which client was using basically. Then probability of fail point of view, we have to see operating history of equipment, current equipment condition, material of construction, traceability of the fluid, continuous deterioration rate of the predicted or expected rates, failure, future inspection and maintenance plans. Here, if we see the same aspect point of view, age-related degradation modes, non-age-related, so which is like a cracking, Hixoic, then accessibility based on operating design and historical data. Here we have a thinning, creep, corrosion under insulation, and all these factors are considered. So in this way, we're calculating probability of failure based on the determined like estimated PCR model or estimated corrosion rate, measured corrosion rate, and long-term, short-term both. Then we assess the equipment like A and B in category 5. There are 14, and in field B 5. Otherwise, the mainly under category 5 are coming thinning point of view 1853 and 3959. Then consequence of failure estimation, economic, safety, health, and environment. So here, economic point of view, production loss, repair cost, labor, and safety point of view, fire, explosion, toxic, and mitigation. With environment point of view, liquid spillage or the gas emissions. So all factors are considered. So these are the basically level 3 assessment on the consequence side for safety, where we take fire, toxic, and explosion impacts, and accordingly rating is assessed. Then economic point of view also, where the production loss, labor, and repair cost, all these costs are added, and overall total business production losses are estimated. Safety point of view, we see that there is a flammability, toxicity, then a VCC possibility, and exposure, and then accordingly released quantity, concentration of the toxic element, release vapor mass, then possibility of averting the danger, whether foreign gas detection system available, not available. This is the environment point of view, which is liquid spills and gas emissions both. So assessment of signal of failure as such. So this was the distribution of the equipment in various ranking. Risk assessment point of view, as a result, like if any particular equipment categorized in the highest, basically there could be a various damage mechanism which may have a different POF, but this is a one which is a dominant one, which is coming as a part of RBI risk. So this could be the assessment of the both damage mechanism, like a failure mode B, and then the overall risk is basically low and low. This is the part here. MIC is coming B as. So risk assessment point of view, then we have to do inspection planning or the confidence in assessment. For example, if the damage mechanism is controllable and the rate of degradation is stable, the process corrosion monitoring data is reliable, or the inspection data is reliable. This is called inspection confidence assessment, and this also have effect for the next inspection and the risk. So then we're getting the next inspection point of view. Next inspection is this, and risk point of view this. So this is the distribution of the items as per the risk point of view, and this is the basically overall risk based ranking result of equipment and piping systems on the term point of view. Mostly one equipment was high, all medium, high, medium, and low. This other way of showing the risk as per the pie chart, and this is the dashboard at the end where we see the how the equipments are distributed with reference to the risk, and how the equipment are distributed with reference to life, and the work order is separate. Criteria for selection of inspection interval, like there are like a risk and criticality assessment, inspection effectiveness and confidence rating, interval planning factor, and remnant life. These are the 4 factors which you use to select inspection interval, like what should be the inspection interval, and then it is basically changed or adopted as per the company policy or strategy. Then scope inspection point of view, inspection location, inspection technique to be used, then coverage of inspection measurement, visual inspections, and inspection interval. All these 4 or 5 factors are basically answered. Like here, we try to answer as per inspection plan, what to inspect mean assess to be covered, then why to inspect applicable damage mechanism, where to inspect location of the inspection or the suspected location, then how to inspect applicable entity technique, when to inspect, inspection date, and inspection interval. So these are the 5 answers which are part of inspection planning process. Here, like legend for plant inspection requirement, we call it PIR for task list. So it is like those are the 5 things that are being answered here. Development of inspection plan, like PIR task list. This is for Excel when we import it, like what activities would be done, criteria point of view, interval point of view, techniques, and resources. The activity description and resources. But these are shown in the software also, and this is like when we make in Excel import template. And this is like in the software how it is shown, and like these are the activities, visual inspection, UT gauging, hardness testing, or there is a profile radiography or UT gauging for those particular equipment and nozzles with the dates and on stream or off stream, what techniques would be applicable. So these are the basically logistic requirement, which is mechanical preparedness, visual aids, HSC caution, other requirements, access scaffolding requirement, and these all things are also defined while doing inspection planning. Then preparation of inspection sketches or drawings, where we are marking, for example, TML, CML mark on the all potential locations, inspection techniques, criteria coverage, and PIA code to be used, anticipated damage mechanisms, and basis engineering design data is also provided. It's like that. So if you see the area, these are the TML, CML points, and here you can see like 100% visual inspection, UTG for this site, then UTG for this site, trail point of view, little difficult for me to read. Then there are like damage mechanisms. Then there's a legend also for the applicable techniques. And this is the normal orientation of the drawing. This is also another inspection technique, basically on the isometric drawing, like how the TML, CML point, there like applicable techniques, there applicable damage mechanisms, and technical legends is also shown. Like you can see that a different diagram is made here. Now, provision and implementation of inspection management system, Velosi provide and implement RBI and inspection management program ISMS is a part of VAIL-Plant software. For RBI, inspection management is an automated tool which will lead to significant improvement in inspection management and risk assessment process. So this is one of the basically report which comes out of the software, which is summary of RBI, which is sometimes we call it also passport. So the finding and recommendation point of view, I will not go through because these are some specific only. And as we do RBI study, we provide some recommendation. But this is the report which normally we generate along with the software, like a study proceeding summary. The first is the exact introduction, then executive summary, and there is a study proceeding summary, what we cover it all, and then there are appendices which we provide. This is the corrosion and inspection strategy point of view, what we prepare a separate document. Basically, it covers like applicable damage mechanisms, their CMP activities, corrosion management program, inhibition program, and how to manage the inspections. Those and it done plant unit by unit practically. Identification of applicable damage mechanisms like general corrosion, mitigations, dead legs, repairs. Each system is also going forward. So this is the one detailed document which is prepared as a corrosion and inspection management strategy. Then I can take like a first question, then we can show. Let's go to software also. We'll take 10 minutes for demonstration of the software, and then we'll go to the question answer as a last. So this is the like a first screen of our software, and here my focus would be on the PEMS. This is the main dashboard. We have a SIMS pipeline, pipeline integrity management system, onshore pipeline integrity management system, offshore PSV, MS, EIRMS means electrical instrument rotary management system, which cover RCM program. Then well integrity management system, CPMS, APMS, and CMS is there. ISMS is also available. So this is the sort of dashboard. When we call static equipment, so equipment which are live is some other system less than 2 years. Then this is 2 to 7 years, 15, and greater than 7, 2 to 8, and this is a risk distribution of that particular facility. Other facility, it is not the previous one. And here, if we collect the tag, then this is a tag where life is over 7 years. And if any particular tag I wish to go, we can select and go there in the system. All right. Now, here if we see history point of view, so here is the inspection history, and you can see attachment is also there, tender report, attachment. So here is the T minimum required, nominal thickness, right? Then metal loss, corrosion rate, and remnant life also is calculated in the system. If more than one inspection, that can be seen also. All the documents which are basically, if you can see here, like, so like if I wish to show my documents attached with this, so, by click of the button, we can see the document, which is a sort of corrosion loop drawing or marking of the T&I Now, RBI point of view, the RBI section here, we will show the damage mechanism. Here we go to the next RBI process. So we got the damage mechanisms are available that those could be calculated. So these values we have to enter and collection can be made by the software. Here with me so this RBI part, then under RBI we have a risk summary of the same which I showed you. And then we have RBI results, and then we can get the report also, inspection plan and so on. Under inspection planning part, so this is a plan which go logistics, then inspection results, and sketch also there. So we can go back to dashboard also here. So how the results are. So this is a demonstration because we just wanted to show a system is there. If you need more details, you can go to our web page and you can ask us. So now we go to the last part of the presentation, which is the question answers, right? And then we'll call the day. So more questions, please.
So one question. In the implementation of this philosophy, you need to have an agreement from the top manager about the budget first. As the first, why or what important or how can the cost saving actually can explain how dealing with these issues in some cases studies will finally result in profit?
See, there are two aspects here. First of all, it's a part of the aim strategy for any companies adopting, like what kind of techniques they will be using for optimizing their inspection and maintenance planning part. So first they would be agreeing to that, and then they will be allocating some budget. Cost benefit analysis point of view is like, see, you have to have inspection planning, whether based on the statutory requirement or your company policy. But when you will be using RBI technique, then it can help you to optimize the inspection program, whether it will be helping to increase reliability or it will be helping to reduce costs. And sometimes it can reliability point of view, confidence in plant condition is always helpful. But in the beginning phase, there could be an increase in cost and then there could be decrease in cost as well. So there is a cost benefit analysis which can be made and which can be shared with the management for the decision-making process.
Next question. What is the difference between RBI and FFS?
See, RBI is a risk-based inspection program, which is like a developing inspection program, whereas FFS mean if you have done some inspection and inspection has reported some defect in the equipment, now there is a decision required whether we need to continue with that equipment in service or we need to remove the equipment from the service if it may carry any risk of like a further catastrophic failure or leakage. So FFS is basically done to assess that condition, whether defect is acceptable in its current condition, or we need to repair it, or we need to replace the equipment. Whereas RBI is simply inspection planning too.
Next question. What is SIL suitable for?
SIL means safety integrity level. This is done as per IEC 61508 and IEC 61511. And SIL is basically for the instrumentation loops which are used for emergency shutdown of the plant. We call it SIF or SIS, safety instrument systems or safety instrumented functions. And as per those standards which I referred, those are used to determine PFD for any SIF. PFD means probability of failure on demand, which is acceptable. Then accordingly, the criticality in terms of SIL 0, 1, 2, 3, 4. And SIL 0 mean reliability as is not required. SIL 1 mean one if you test that loop 10 times, it should fail only one time. And SIL 2 mean if you test that loop, any particular loop 100 times, it should fail only one time. Or SIL 3 mean if I test that particular loop 1,000 times, it should fail only one time. It depends on the criticality of that loop, what kind of reliability level you need. So SIL itself is a big subject. It is equivalent to RBI, I would say. It's not so simple to explain in 2 minutes time.
Next question. Does RBI cover pipelines?
Yes. Basically, RBI program covers pipeline, structures, static equipment, and piping system at plant.
Next question. Why can we not? Why we cannot perform RBI for rotating equipment?
You can do that, but RBI scope is limited to the damage mechanism which are coming from API 571, or it is coming with the support of API 580 and 581. Whereas there are many other parts, let's say electrical motor, its wiring issues, or its shaft and bearing issues cannot be covered by RBI as such, because the rotatory parts which may be causing failure due to bearing failure or misalignment of the shaft, or there could be high vibration. So there could be other issues, other drivers. So that those are covered under RCM. In general, like as I showed in the earlier stage, the RBI, SIL, and RCM, they work in parallel side by side. Some of the RBI related issues are also discussed and covered under RCM program. And similarly, if you see SIL program, in SIL, there's ESD valve. Under ESD valve, there's a body of the valve, there's a stem of the valve, there's actuator. So there are corrosion issues as well. And like PSV also have a corrosion issue with the disc and its body. So there, some of the RBI activities are also covered under SIL and under RCM program, but there is a requirement of corrosion and inspection people is called on requirement basis.
Next question. Is asset integrity a part of RBI?
Basically, RBI is a part of asset integrity.
Next question. How can we define risk levels in risk matrix like low, medium, and high?
There is shown as if you remember in the risk matrix, it is shown middle, right side and left side, upper corner and lower corner. High risk in the right upper corner and low risk is bottom right corner.
Next question. Under which inspection the tank bulging? I think we already
bulging is not covered under RBI because it's a design failure. Because if thickness is less than the required pressure, then it would be bulging.
The main difference between RCM and RBI?
See, RCM are two mechanisms. One is a classical RCM, other one is FMECA based RCM. And RBI is three type of RBI: qualitative, semi-quantitative, and quantitative RBI. But techniques point of view, the damage mechanism and failure mode in both approaches are similar, but their mechanism is a little bit different.
Next question. Can you throw some light on qualitative methods?
Qualitative is so simple. For example, let's say if you got a separator with hydrocarbon service coming from a fluid is coming from a well containing hydrocarbons. So you can say, okay, what could be the damage mechanism? CO2 corrosion, or there could be some erosion corrosion, and then say what could be the probability of failure. So maybe like once in a 10-year time or once in a 5-year time, the probability is selected. And then you discuss it on the consequence point of view. If something fails, then what could be the effect? Or maybe it can damage the equipment, there could be a fire, and there could, if operator is around, it might be injured. So what is the consequence? Let's say E or C or D, and probability A and B. So then by combination of both, you can assess the risk. So it is a simple and it can be done on qualitative discussion or judgmental basis. Whereas quantitative, you need to have more data and accurate data to decide.
Next question. How do you link RBI recommendation and OSI?
See, outcome of RBI, like in Saudi Aramco culture, they're using OSI and the TNI program. OSI is on-stream inspection program. So RBI give you like a effect, like the results, like what kind of inspections are required for on-stream or for off-stream.
Next question. What is the difference between asset integrity and mechanical integrity?
See, previously OSHA was using term mechanical integrity, and now term is used asset integrity. Mechanical integrity was excluding electrical and instrumentation, or sometimes structural also, you may say, or civil. So asset integrity can cover all disciplines, including like a mechanical, civil, structural, electrical, instrumentation. So asset integrity is better term than the mechanical integrity.
Next question. How to familiarize operations shift staff on what to inspect, how to inspect, and why?
See, operation shift staff is normally they are basically trained, or they're given training or orientation to look at if something is leaking, something is vibrating, or there is any abnormality on the facility as overall, right? And as such, they will not know what is happening internally, but of course, if any leak happening, they would be able to report. If any high vibration we should be able to report. If any condition, for example, like integrated operating window in terms of temperature exceeding or in terms of water content in incoming gas increasing, so they can ring the bell and they can involve decision maker for corrective action.
Next question. Could we prevent corrosion?
Yes, that is the purpose of the corrosion and inspection engineers. If corrosion would be there, then plant will not be able to live longer life. So let's say external corrosion, which is normally caused by atmospheric, the painting program is there. While building new plant, we always take care what service would be there, what corrosive elements would be there, whether this material would be sustainable with the prevailing service. And similarly, corrosion allowances are provided. So as if the metal loss would be there, still plant would be able to complete the design life. So it is manageable, and that's why all these plants are working.
Next question. What are the factors that determines the use of qualitative, semi, or quantitative approach?
So that depends like how much effort you wish to do. Basically, qualitative can be done easily. Quantitative is more time, and but quality is more better, and semi-quantitative is in between.
Next question. What is the role in management of change in RBI?
See, management of change, if any service is being changed or any parameters are being changed in the plant or there's any modification being done, or that effects can also be covered under RBI study.
Next question. Can we do RBI for casing assembly of rotary equipment?
Like we are used to do sometime, but if you can see that as such, there's no formula or Hoop stress formula applicable on the casing of the pumps or compressors. But if to assess if there's any damage mechanism applicable, assessment can be done. I remember in old days we were used to do, but nowadays the rotary equipments are being taken away from RBI and they are being handled under RCM program.
Next question. Why DOW is not considered seriously for RBI?
What?
Why DOW is not considered seriously for RBI?
DOW is new for me, I don't know.
What is the most essential data to collect on quantitative risk assessment?
See, data is more or less same, but like the PFD, P&ID, equipment data sheet, piping isometric, then inspection history is important, heat and material balance is important, but data is more or less same, but you need to have more detailed robust calculation for the quantitative work.
Next question. Can RBI be used for other industries besides oil and gas and petrochemical?
No, yes, it can be used like a pressure vessel or pressure vessel. Piping is the same. And if you are using it in pharmaceutical, cement industry, paper industry, any industry, you can use this technique, no exception.
What about pressure casings of rotating equipment? Can we cover under RBI? What's your experience?
As I said, it can be covered, but generally it is covered as a part of RCM program.
For pipings, how circuitization will help in RBI?
See, circuitization is a technique which are being used as a part of this GEAPM. If corrosion circuits are further subdivided into the piping circuits, which can be made as a one group in the inspection program.
As per our slides, POF depends on two factors. Can you please repeat and elaborate?
POF, like one is the applicable damage mechanism, and the second one is the inspection history.
Have you linked RBI with another reliability tool? Can you give us some examples?
Yes, like if RBI program is software is linked with the SAP or Maximo, Oracle, or our own CMS system, there is a link in the reliability program. Yes, or APM.
Next question. Does one have to know API 570, 571, and all other damage mechanisms before they can get certified in API 580 and 581 and apply it thoroughly?
No, API 580 certification program is there. These all certifications are independent of each other. If you are appearing in a 580 program, you can pass without appearing in API 570, 510, or 653 program. All these programs are independent of each other.
Next question. To set probability of failure via qualitative analysis, is there any written documents need to prepare, or else knowledge or experience can get you POF through qualitative methods?
See, qualitative, semi-quantitative, and quantitative methodologies are well described in under 580 and 581, and those documents can be used as a reference while doing RBI analysis.
Next question. What is the methodology for the non-metallic piping systems and tanks?
See, there's always a question for non-metallic part. So it is a combination of maybe sometime RBI or RCM or failure mode analysis. Because non-metallic, the mainly issues are with the base material, which you don't see in the steel as such. And secondly, the workmanship, which like mostly the non-metallic GRE pipe or yes, GRE is the main. Your all joints are by solution, and those could break with the passage of some time, and you don't have that kind of pre-qualification program.
Next question. How RBI can be helpful in offshore structure platforms?
So we are doing it as a mechanism as per API 2 SIM, and that program is being developed and being used by all offshore companies almost.
Next question. Is the risk matrix shown specific or is it general?
It's general.
Next question. What is the difference between RBI and non-RBI?
See, non-RBI means you may go without doing RBI process, you can still develop your inspection program by following time-based technique or run-to-failure technique. So this is a part of your strategy.
Next question. Can you provide some RCM codes that are available?
RBI, see, RCM point of view, there is a JIS code is there, 1101, 1102. There is a basically 6120, 6112 is also for FMECA. It is ISO 14224 standard. So the various RCM standards are available. Yes.
Next question. Is RBI only limited to pressure containments?
See, structure is not pressure containment, it still can be used. So it's not necessary, but it can be used for the most of the static equipment, structures, pipelines, equipments. Some sort of technique can also be used, structures mainly, and it is like a basic code API 580, 581. So they have defined what equipments can be covered under API 580, 581 base program.
Next question. What is the accuracy of an inspection and is it performed on field?
See, there's assessment on the confidence factor, whether the technique is effective, the coverage is enough to ascertain the condition of the equipment or piping system. So that complete chapter is available under API 580 and 581, and those could be referred for use.
Next question. Is RBI covering ruptured discs?
See, rupture discs, PSVs are covered. Rupture discs are mainly one-time use, or those parts mostly OEM recommended. Like if a rupture disc is like erupted and then you have to reset it. So those are as per their manufacturer. RBI program is not covering rupture disc as such.
Next question. What are the key factors that are considered when assessing the risk of equipment failure in an RBI study?
There is a complete step here going forward. I said there are all damage mechanisms are there, the history is there, remnant life is there, and then consequence part. So it is a complete step which is the whole presentation I covered today.
What is the difference between the inspection of API 510 or 653 and RBI 580?
See, 580 is our risk-based inspection program, which is developing inspection program, whereas API 510, 653, they are inspection guidelines, like how you should inspect equipment or pressure vessel or heat exchanger, and how you can inspect API 650, API 620 big tanks.
Next question. Kindly explain whether civil structures like cooling towers, foundations are covered with which advanced proactive methodology?
See, RCM, failure mode effect analysis, can be used for the civil foundations as well. And there is a ASC 11-99 standard, which covers civil condition assessment and life extension studies. Those approaches are used basically.
Next question. How can you apply RBI on an equipment failure like over pump bearing has been damaged?
See, those are under RCM program.
Next question. Why API 970 says this in 5.7 damage mechanisms, API RP 581 should not be used to determine expected corrosion rates. Its purpose is to set inspection priorities. Thus, the rates listed are simplified and may be overly conservative.
See, there's the academic discussion, like what kind of damage mechanism, what corrosion rate, like what scenarios, under refractory, underlining, without climbing. So that's an academic discussion. When we are like experts are talking, they can talk, but for normal working practice, these are not the issues to be tackled at this stage when we are saying how a basic RBI process to be followed. So RBI is a very beneficial when you will be applying it. A technique point of view, it carries certain negative issues which are caveat, for example, capability of the doer, then availability of the data, and the kind of the efforts added in. And if these things would be applied, then RBI can give good result.
Next question. What is risk priority number and how is it calculated?
So risk priority, that is like a position of any equipment when you ranking the risk, right? Whether it's a multiple of PUF and CUF, and then accordingly categorization.
Next question. What are the criteria that could help to select the best RBI methodologies?
See, it is basically the kind of effort and the result. Like you can do risk ranking by qualitative, and then you can select high risk for the quantitative risk, and others could be semi-quantitative, or you can apply full semi-quantitative or full quantitative as well. The different companies are using different approaches, and it's a combination of both.
Next question. As RBI is for static equipment, does it also covers furnaces and burners?
Furnaces are covered, burners are not covered. Burners are covered under BMS program or under RCM program.
Please guide us about the corrosion loop drawing, its significance, and how to develop it.
So API 571, there are chapters, the guideline available, and also under API 581 guidelines are provided how to develop a corrosion loop.
For HFOs storage tanks, after how many years RBI inspection, NTT and UT, is recommended as per API and NFPA standards?
See, in general, if I go to API 653, off-stream inspections are being recommended after 10 years, but on-stream inspections are maybe every 5 years, and that depends like condition of the circumstances as well.
Can RBI be implemented to subsea production systems such as subsea pipelines, Christmas trees, subsea manifolds?
See, subsea pipeline, subsea structure is being applied, and also for the subsea other assets, RCM technique could be applied, but it's a combination of both the techniques are applied under subsea assets.
Now, next question. A company have inspection department. Why they hire relative company for RBI team and spend huge amount of money? Difference between inspection department in industry and RBI?
Well, see, under inspection department nowadays, there are inspection engineers, there are NDT engineers and technicians, and there are also corrosion engineers, and there could also be RBI specialists. So this is once you have an implemented system. But at the early stage, it is just like making the complete databases, making all the corrosion loops, all the hundreds and thousands of drawings. So those activities are being subcontracted to specialist consultants like us, and those jobs are being done first time by an external consultant. This is normal approach. But once system has been implemented in use, then it's better to have like these disciplines, as I said, inspection specialist, entity specialist, then corrosion specialist, and RBA specialist. Sometimes FFS specialist also.
Next question. What is the definition of IOWs?
Integrity operating windows, like level, temperature, pressure, flow, what would be the highest and lowest limits.
Next question. If I want to establish a maintenance and inspection of structures, what should I use, RBI or RCM?
For structure is RBI, but it's onshore or offshore. It is onshore mean the AISC standard guidelines are there, and or ASC 11-99. For offshore, API 2 SIM standard is there.
Next question. Whether the RBI can be integrated with digital twin, predictive maintenance, digital analytics, etc.
See, RBI program, this is also the digital, like over API VAIL-Plant, so it is also digital twin program in all the electronic data interfaces. Yes, it's available. It is just a terminology.
Next question. What's the impact of damage factor in POF analysis? General guidelines.
See, there is a detailed quantitative methodology with the generic frequency, damage factor, the confidence inspection, age. Those are the multiples for calculating the POF or likelihood of failure calculations.
Next, how ILI results can be understood in RBI perspective for
See,
cost.
ILI results are telling you where the defects are and location and size of the defect, and then RBI program can help to assess like what are the causes of those defects and how those could be prevented and what could be the frequency for the ILI program.
Next question, what are the preventive programs in RBI?
See, corrosion inhibitor program. Number two, online meeting like weight loss coupon, ERP probes, and then inspection techniques what you use online, offline. So these all are the preventive programs.
What are the equivalent guidelines other than RBI?
See, RBI equivalent guideline could be covered as under like a normal inspection program, which are advised under API 510, 570, 653, API 572, API 574, or maybe also API 661, API 662 for the heat exchangers.
Are risk matrices developed based on extensive inspection plans?
No, these are as per the company policies or practices.
How did you manage damage factor calculation for management system factor FMS with your client? From where you get all the information?
See, if like let's say E to G software with API RBI, they use 0.5, or you can get the data as per there was a previous standard. There was I don't remember the latest standard. There was one appendix where all the questions and the rating was given. If you go through that process, you could do estimation of the management factor.
Next question, is RBI useful in ERM?
See, terminology point, I'm not sure ERM mean what does ERM technology word mean. You know, API 584 is like a integrity operating Windows related standard.
No, we can do last question. Is it fair to say that you can't extend the inspection frequency with RBI unless you have performed a baseline inspection? This is an important question for greenfield projects.
See, for greenfield program, there should be some ongoing inspection program, and without the knowledge about the health of the piping and equipment, no program can work. So inspection and theoretical studies goes hands in hand. How much inspection at what frequency, that is the decision RBI helps to make. Otherwise, without inspection, you cannot run your plant without the fear of failure. Okay, sir. Thank you very much for the day, and it was very interactive. A lot of questions came in, and we look forward to seeing you in the next upcoming webinar. And till then, thank you very much, and bye-bye.